Digital to analog converter. So this is the one of the application of operation amplifier. That is in this digital to analog converters, we are using the APAM as the key for converting the process. So let's see what is a digital to analog converter. So before that, we need to know what is analog signal, what is digital signal. So analog signals are always continuously varying with respect to the time period, but digital signals varying with respect to the particular time intervals only. Okay, so some of the circuit we have two systems. One is analog system, and one is digital system. When we are sending the data from one system to another system, means it will be very difficult to analyze the data. So we need to convert according to that system. So that is digital to analog converter and analog to digital converter. So digital to analog converter converts analog signal to the analog voltage. Okay. So that is digital signal. So digital signal means zeros and ones. We are going to change the zeros and ones into the output of some voltage. Okay, these are the models of DAC and ADC. The basic concept that we discussed. So in type of DAC, okay, digital to analog converter. So digital to analog converter types, we have two types. One is binary weighted resistor, another one is R2 or ladder type DAC. That is, first one is weighted. So what is my weighted resistor? Okay, so weighted resistor means wait. Binary resistor is weighted resistor that is utilizes the summing op-amp amplifier. So that is weighted resistors are used to distinguish each bit from the most significant to the least significant. Okay, that means we are giving inputs. Okay, zeros and ones we are going to give in the MSB to LSB order. So according to that, if MSB connected to R means that is order, the next value will be connected to the 2 power or 2 power NR. So like that. So that is value of resistance will be varying with respect to the number of bytes. Okay, this is a basic idea. So this is the basic circuit. So it is a inverting amplifier because we are giving input to the inverting terminal. Another terminal will be connected to the ground. That is non-inverting terminal connected to the ground. So here we have different reference value depend on the number of bits. If it is 4-bit means 4 reference value. So these are connected to the different resistors. Okay. So the output voltage V out is equal to I into RF is equal to VR into RF divided by R into D1 2 power minus 1 plus D2 2 power minus 2 like that, etc. Okay. So that is simple weighted resistor DAC. So transfer characteristics of 3-bit DAC. That is 3-bit value will be varying. So this is the example for if we have 0 to minus 15 voltage reference means you will get the different digital value according to that. Okay. Basic model. So this is the simulation output of the weighted resistor DAC with the input and the output. So that means if I are giving reference voltage of minus 5 means the digital output will be 111. So analog output will be 4.3. Okay, that is maximum means you have to get 5, but in the real time fluctuation you will get a 4.5 to 5. Okay. Weighted resistor and input, second input and example. So next one, that is switch variations. So like that you can see the switch variations 101, 110 like that we can get the output. Okay. So in weighted resistor model, if you are going for the if you increase the number of bits means the resistance value will be more high because every bit we are varying the inputs, that is 2R, 2 power 2R, 2 power 3R, 2 power 4R like that. If you're using 8 power means 2 power 8, 6, 8 or R. So that means it will use a 250 mega ohm, like that it will be taking. So if you're using the circuit for this more number of values means you will get a layer noise in the output. Okay, so for reducing the number of resistor and resistant value, we go for the R2R resistor. Here they are using only two resistor. One is resistor R, another one is 2R. Okay, if we are using 10K means it will be 10K and 2K resistors. Okay, that is only used in the R2R layer DAC type. Okay, this is the model. Sample input on the output of digital to analog converter. So this is the IC package for the DSC, that is monolithic IC 1408. So most of the circuits are, this is a 8-bit model. So that means output will be a 8-bit. That is the input will be a 8-bit, output will be a some reference voltage. What we are giving, it is a 10 or plus 12 like that. We can given through the process. Okay. Digital to analog converter applications. So DSs are used in the digital signal processing, also used in digital power supplies for microcontroller. So DSs are used in the digital potentiometers, weighted resistor, high resolution and accuracy can be achieved. So DSs are simple and implement. Same as it is having different disadvantages. That is gain error, offset error, non-linearity error is commonly caused by the resistor and capacitor in the circuit. In R2R ladder, converts delay is caused as the circuit needs switching based on the inputs. So next one ADC. So we know that simple analog to digital converter. That means we are going to convert the analog signal. So we are comparing the previous reference voltage. You will get the output through the GCM. Okay, so this is the concept of ADC. So there are different types of ADC. That is flash type ADC, successive approximation ADC, single slope ADC, dual slope ADC. Then are different models. Let's see one by one. Direct type ADC. So it is high cost ADC. So depend on the number of inputs, the comparator number of comparators will be varying. If you're using 6 means you have to get 8 comparator uh, machine from the input and the output condition. Okay, so it is not mostly used because it is costlier. Because here we are using number of successive approximation type. So in flash type method, flash type direct method, it is having a more cost and a more number of components used in that. So it is going for the successful approximation ADC. So in this ADC model, okay, so a successive approximation register are taking the reference. So taking the reference from 0 and it is converted into the analog value and compare with the previous value, then you will get the output. Yes, that is a repetition format. That is repetition and identification process will be done by the process. So successive approximation example. Next is single slope and dual slope. So this is the single slope analog to digital converter. This is a dual slope analog to digital converter. So this conversion convert analog into digital ADC using the method of time to voltage conversion as well as the sigma or the sampling converters. So these are the ADC and DAC. So most of the circuit using the ADC and DSC with respect to the number of students participated in this concept. Yeah, thank you. Remaining we will see in the next class.